So once we know that an equation is in fact a function, we can change the way we write it. And so when we have y equals 2x plus 1, that's a linear equation. That's the example we did earlier. And once we establish that it is in fact a function, and it is, we no longer write it as y. When we want to emphasize that it is a function, we can use what's called function notation. And function notation looks like this. F of x, it is a function of x, the output. So we called y the output earlier. And f of x is also the output. The output is a function of x. It depends on what x is. And so we now write f of x equals 2x plus 1. The output, which is a function of the variable x, is found by doing 2 times whatever x is plus 1. And so you'll see f of x used, but the f part is actually arbitrary. We could use any other letters, and so you'll regularly see things like g of x equals x squared plus 2x plus 1. You might see h of x. You might see p of x. The letter used in to name the function is arbitrary, but it's typically a letter, and it's going to be next to the variable that's used in this equation. So f of x, g of x, h of x, I could say p of y, the function p, which is a function of the variable y, and then have y squared plus 9. That would be the function p, which is a variable, which uses the variable y. It is a function of y. So know that functions are typically represented with letters, and in parentheses will be the variable used in that mathematical relationship. And so you'll see them lots of different ways. Our textbook typically sticks with things like f of x, g of x, h of x, but you can see all sorts of different functions. In later math classes, they expound on this, and you typically see more of those. So what does it mean to evaluate a function? So I'm going to start with the function f of x equals x squared minus 5. That is a function, and when you are given it to you in function form, like I just did right here, you are allowed to assume that it is a function, that it meets the definition of a function. You don't have to prove it every single time. When it's given to you as in function notation, it is a function. But what you'll see sometimes is this, something like this. It's called f of 2. You would read that as, what is f of 2? And f of 2 means, we know that this is, the f function is a function of the variable x, right there. F of 2 simply means this is no longer a variable we don't know what it is. We're saying that it's 2. We're saying that variable for right now, we're going to evaluate this function when x equals 2. And what that means is we're literally going to substitute in a 2 everywhere there's an x in the equation. So f of 2 means evaluate that function when x equals 2. So I plug in 2 right there, and I'm being very strategic in how I model this. You always want to substitute in with parentheses. And the reason we do that is because when you start dealing with negative numbers, which we'll do some examples in a second that have negative numbers, it can become very easy to screw up your positives and your negatives. You want to make certain that you substitute in parentheses because it will help you minimize the mistakes you make with signs. So f of 2 means plug 2 in, and then it's simply order of operations. 2 squared is 4. And so I have f of 2 equals 4 minus 5, which means f of 2 equals negative 1. So when you see f of 2, that means evaluate the function f for 2 as the 2 is plugged in for x. And what do you get when you plug in 2 for x? So in this case, this is f of 2, the function evaluated when x equals 2, gives us an output of negative 1. And so we could represent that f of 2 equals negative 1. We could also say when the input is 2, the output is 1. Now, if I, for the same function, said, what is f of negative 2? What is f of negative 2? Well, that means plug in negative 2 into that function. So I have, instead of x squared minus 5, I have negative 2 squared minus 5. And so I have negative 2 times negative 2 is 4. And it turns out that f of negative 2 is also negative 1. And so these two outputs, inputs and outputs, these two combinations, these ordered pairs, are for that mathematical relationship right there. The function of x when x squared, for x squared minus 5. So we can plug in a lot of different things. If I said, what is f of 3? You would plug in 3. Just like we plugged in 2, you'd plug in 3. If I said f of negative 10, you would plug in negative 10. But we don't have to just plug in numbers. I could say, what is f of negative x? And this is something we're going to see in subsequent sections. F of negative x. That literally means everywhere there's an x, plug in negative x. So that's going to look like this. Negative x squared minus 5. I could say f of y. Plug in y. So that becomes y squared minus 5. I could put in full-blown ugly algebra and say x plus 1. Whatever we plug in, even if it's ugly. So this means I'm going to plug in x plus 1 everywhere there's an x. X plus 1 squared minus 5. You plug in whatever you're asked to plug in. So f of x is our normal starting point. And it says evaluate for these different things. All these different things simply mean plug in whatever's in there back into where x was in the given function.